So today I'm visiting Mike Harwood, who has many years experience managing and designing high-speed analog and RF circuits, and has growing interest in antennas, and indeed has designed his own very compact active magnetic loop. And he's helping us here at SDRplay assess some of the more popular options for HF and below when it comes to active magnetic loops. So we're hoping over the coming weeks to have more videos and comparisons to help show the various pros and cons of different makes, models and designs.
That's right, John, and I've done some work on this already and we'll be doing some today, and hopefully this will be of interest to just a wider audience.
Okay, we're looking forward to it.
Here's a list of some of the antennas we'll be looking at. The Wellbrook 1530 being very much our benchmark. We'll be looking at the Bonito Megaloop FX, the cross-country wireless active loop amplifier, and the LZ1AQ active loop amplifier. And over time we'll see how Mike's own experimental compact loop designs are coming along. And to kick off, we'll have Mike talk a little bit more about how he's using an RSPduo for the comparisons.
What I'm doing at the moment is working on an antenna development, and I want to perform some benchmarking with some of the industry standard antennas. For example, one of the Wellbrook loops, which seems to be fairly universally recognised as a good antenna. Now, with comparing antennas in the old days, what people would typically do is have a radio tune into a signal, move over to another antenna. Is one better than the other? And a good comparison is very difficult. However, with the SDRplay RSPduo, which has two tuners in it, it's very possible to look at a whole spectrum for two antennas at exactly the same time and therefore compare their performance, which is a very good way of assessing how the two are the same. And then for a wideband antenna, move between different bands and compare, say, on a broadcast band like the long wave band, how they compare, then move through the amateur bands all the way up to 10 metres. So what we have on the screen here is a somewhat very crudely put together a comparison between, on the top we have the Wellbrook 1530, and you can see here on this is now looking at the long wave band. This here is slightly off screen. I can move it back on screen. This is the Droitwich 198 kilohertz radio 4 transmitter, and we can see that we get a signal to noise ratio around 49-50 dBs. This is an experimental antenna, much smaller than the Wellbrook loop, in fact a 1/16 of the loop area, and we're getting about 41 dBs of signal to noise ratio. So although some more optimization is needed here, so actually we're just optimizing it, I'm again getting a few more dBs out of this, so there's probably about 7 dBs difference between the two, but there is a factor of 16 in the loop area. So this gives me some idea of what needs to be improved going forward in order to make the performance more comparable. Okay, so this is an experimental antenna, very experimental. You can see that the mounting mechanism is just on a plastic wheelie bin, mainly chosen because it doesn't have very many metallic elements within it, and it's about the right height and it's sufficiently stable. This is a experimental loop. It is 2 turns, 25 centimetre diameter, which that gives you an effective height difference of a factor of 8 between, say, a 1 metre loop. And this then has some very low noise electronics inside it, and a 50 ohm output to drive the RSPduo. One interesting aspect from this is the amplifier is designed to work from low voltage. It works down to as low as 3 volts with a estimated noise of around 300 picovolts per root hertz, and because it works down to a low voltage, it can easily be interfaced directly to the bias T within the RSPduo, which gives a 4.7 volt nominal output, and that allows it to get its power supply without any, or get its power source without any external power supplies or bias T networks outside that of the RSP. And this here is the reference loop which I'm using to compare the experimental antenna. This is a Wellbrook ALA 1530 loop, which is widely used within the industry and is used as a benchmark source, so that for all the different antenna variants that are developed, we can develop a comparison figure between this and a new one. And so for reference comparison purposes, as well as having the Wellbrook loop, we have here a Bonito, also a 1 metre loop, the Bonito Megaloop FX, which is a commercial construction which we use for comparison purposes. Here we have a hybrid construction. This is in fact the cross-country wireless a loop aerial. It comes supplied with like a wire loop which you can form yourself. However, to have some level of consistency in the comparison, I've made a fairly crude 1 metre diameter microbore central, this is really a plumbing pipe in a insulating PTFE housing, really another pipe of slightly larger diameter. Connected to here we have the cross-country wireless loop amplifier, and then there's a separate box with the bias T. And here, this is a recent acquisition. This is the LAZ1AQ loop, which is, and the box here with all the circuitry inside, that's the amplifier. Again, it's a two-box solution. There's the head amplifier and also the bias T, and maybe some sort of galvanic isolation as well, and also the power supply. So again, a very comprehensive product, but slightly more complicated. And here we just have another loop. It's 1 metre. This is for comparison purposes, so if I want to compare the amplifier that's been developed with the 25 centimetre loop and then compare it to a much larger, or compare it to the same loop as used with the other antennas, I can connect this into the 25 centimetre loop and then get comparative benchmark figures.
So watch out for more videos reviewing popular antenna designs, and there'll be links to these from our antenna suggestions page as part of the miscellaneous section on the website www.SDRplay.com. And if you have suggestions for antennas you think we should be looking at, please let us know by contacting us via feedback@SDRplay.com.